there can be loading tools, things like that, right? So in order to, collaborate with all those jobs or all those tasks, we need some mechanism to bind them all together. Okay, so take it. Let's help to understand this in this way. For example, you have some component. You are fetching data from one of your traditional RDBMS systems. Okay, you are, for example, fetching the data uh, of a particular set of customers, their geographic locations, and all of that stuff, right? And you want to calculate, you want to do in the end uh, what all geographies they have been present in. So, for example, there can be some set of customers who are from North region, some can be from South region, East and West, likewise. Right now, this is a very basic example. Examples like these, are not a practical use case, a real world problems. But yeah, for the sake of understanding, let's take it this way. So, firstly, we took the ingestion part of it, right, wherein we particularly targeted the RDBMS. That could have been our Oracle, that could have been our SQL, Postgre, anything, etc. Okay, so we particularly ingested the data, we consumed the data from there, right? We simply pushed it into some of our processing framework. Okay, so for the ingestion part, we could have used Kafka, Scoop, etc., etc. There are plethora of options available. Now coming to the processing part, we go to Spark, Flink. Again, that's not in the scope of this session. So let's keep it that way, that there is some processing tool which is helpful in calculating all those info related to the geography of a particular customer. Now, once you have that information, then you have a loading pipeline wherein you load that data, possibly in some dashboards, possibly in some other database downstream customers. You can also present your data or push your data to your downstream customers. So there can be a number of use cases here, right? Essentially, if you talk about, there are three major components here. One is the ingestion part, the second is the processing part, and the third is the loading part, right? In other terms, you can also call it as ELT or ETL. Though again, that's something still different from this. But just for an understanding purpose, let's take that example into consideration. So now I want my pipeline to be run in such a way that firstly my ingestion jobs run, then next my processing job runs, and thirdly my loading runs, right? So I want to bind it in some way. So that binding, that task is done by Airflow or any orchestrator tool for that example. Okay, I'm pretty much sure it would have given you some glimpse of what we are going to talk about today. Let's move ahead. So here the agenda talks about the quick introduction of Apache Airflow, the components, we'll be seeing the demo, a live thing in action, the resources, conclusion, and Q&A. Okay, so I think already this has been covered about me, but yeah, you can feel free to reach out to me over LinkedIn, right? And so about me, okay, I'll take a quick brief about myself. So I have a strong experience in big data ecosystem, designing and developing pipelines and architectures. Core competencies include big data engineering and analytics, design and development engineering, enterprising data warehouse solution. And I'm an avid reader who is into writing blogs, articles, and has been editor of some magazines and newspapers. I aspire to teach and learn through writing. Hobbies include love listening to music, play guitar, book nerd, let's make learning fun. Right. The last line is something which should be of the utmost importance here. Okay, let's move forward. So the first slide, which says quick introduction to Apache Airflow. So the first is, what is Airflow? I think we already discussed about this in a couple of minutes ago. So particularly when we talk about Airflow, Airflow is similar to other orchestration tools. Okay. So primarily, if you have an exposure working in a bank, then you might have also worked or heard about Autosys. It's a very, very famous orchestration tool, which is very traditional age-old system. So it's similar. Next, there comes Uzi, right? Uzi is also one of the orchestration tool which used to, be there for some while. Airflow is one such tool. Luigi is one such tool. So, depending on your need, depending on the project's requirement, depending upon the expertise of the team and the resources, it's essential to choose one orchestration tool. It's not that we are talking about Airflow, so Airflow is the best. But yes, it has multiple components which is able to handle majority of the problems which an orchestration or a scheduling tool can solve. Okay. So now we move here next to need for an orchestration tool. I think we just discussed binding all the pipeline, all the tasks together. Now, one more question I think can come up is it only a sequential pipeline which can be binded together, or there can be other parallel tasks which needs to be done together? So for example, we have a task A, right, and a task B, right? Now we want, and under task C, task D, and task E. Now we want task B, C, D to run in parallel after A before E, right? Before E. So the DAG, we'll talk about the DAG in subsequent chapters and subsequent slides. So the first task would be A, second would be B, C, D, and the last would be E, right? B, C, D are in parallel. Can we do that? Yes, definitely we can do that. So that is the whole purpose of an orchestration tool. You do not just have to be sequential. You can also work in parallel. You can also change the hierarchy altogether. So that's the whole point of an orchestration or a scheduling tool. Let's move forward. So what's the difference between an orchestration tool and a scheduling tool? So we already talked enough about the orchestration tool here. Now let's take a brief glimpse into the scheduling tool. Scheduling tool, think of it as a typical cron job, right? So those of you who are from an IT background, they must be aware about the cron job. If not, I'll give you a brief glimpse of it. So a cron is an expression which is, in this format, star, 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 right? And one star means day, one star minutes, hours, days of the week, month, etc. So you can basically schedule your job to run in that interval. Okay. For example, think of it this way: you want your job to run 2 a.m. daily. Okay, 2 a.m. IST daily. So your cron expression would look like you want to run at 2 a.m. right? So day would be star, that you want to do it daily, right? Now you just want to the hour time to get changed to 2. So star star 2 star star or something like that. That's going to be the cron expression. Okay. Typically, that is the cron expression which has been the age-old system in all the Unix-based systems or Linux-based systems. Now, all the scheduling tool, they just have a fancy UI over it. Underlying thing is your cron job itself. So in the Airflow, you also have a schedule interval kind of an option, wherein you can set in your interval when you want your jobs to get run. Okay, we'll see this in demo. So at that point of time, it would be much more clearer. Next, let's move to other orchestration tools available. So I think we already talked about this: Uzi, Autosys, Luigi, etc. Right? How does Airflow fit in a typical data engineering pipeline? Okay, so we talked about this also, that it's just for the orchestration and the scheduling tool. There is one more, there is one more utility which is there from quite some time now, right? So for example, what happens is, it's not a very good practice though, but yeah, I've seen it also. So Airflow also provide the capability for that. What happens is there can be systems or there can be code bases which can also be handled using Airflow. Okay, so for example, there can be some external library or some external plugin, and you need to do something over that plugin or something over that library, and you are just writing that piece of code into your Airflow. Okay, so even if Airflow supports that, and that is a good thing to do because you want to make proper use of that plugin, but that thing should be minimized, right? Minimized. I'm not saying should be completely eliminated. It should be minimized, because the more you overload the orchestration tool and make it a computation tool, right? You're just overloading something. So for example, Airflow is designed in such a way that it's plainly for that purpose, right? Computation should be minimized. And so what happens is, for example, you are using a very bare minimum machine. In terms of AWS, we can say M5 X large, let's say, right? Or some, or even bare minimum machine, for example, 2 GB memory or 2 core system or something like that, right? Just a made up thing, right? I'm not saying that that kind of a configuration Airflow would very well work in. So there, I would assume Airflow can run pretty fine because it's just an orchestration tool. It just needs some memory, some level of memory for its processing and all of that. It does not need a huge level of computation or a CPU or GPUs or all of that, right? Therefore, it's advisable to keep computation and orchestration aside. So that's one more use case where Airflow is typically seen in these days. Let's talk about the major versions. So there have been a couple of versions which we have seen these days, but the major versions are Airflow 1 and Airflow 2. 2 plus, 1 plus, right? Now majority of the things have been moved to 2 plus, and it's always advisable to go for the latest version because it has all the bug fixes, improvements. So yeah, that's what about the Airflow major versions. What not to do in Airflow? Good practice, code overloading. This is something which we just discussed a couple of minutes ago. Best data quality practices included with Airflow. So yeah, okay, this is a good point. DQ, great expectations, etc. So what happens is, people from data engineering background here, right? For example, what happens is you have created some data, you have created some pipeline, your data is flowing pretty much fine, but now you want something to have an observability. You need data profiling or data observability. You want to validate your data. Okay, so tools like these are tools, I would say these are libraries which come into play. And Airflow also provides the capability to get plugged in with them, right? DQ, great expectations, etc. So you can think of these as your Monte Carlo, right? If you are aware about Monte Carlo, it used to be a very very good and a traditional age-old system of keeping a quality of data in check. Okay, so that is one thing. Next is Airflow connectors, Slack, DBs, cloud platform, etc. So Airflow also provides a range of connectors, right? You can connect your DAGs or your Airflow systems to your Slack notifications. For example, you want to get notified whenever your job gets passed or job gets failed. So that's where your connector of Slack would come into picture. For example, you want to connect into some RDBMS or some other database. Okay, you directly want a DAG or you directly want a task to be consumed or to be handled from that particular DB. So then in that case, the DB connector would come into play. Any cloud platform, for example, if you want something to be, something to get connected with the AWS per se, or your GCP or your Azure, etc., then that flexibility is also provided by Airflow. Programming language support, it's mainly Python. So Python is something which is there, right? You can also write pretty decent and smaller functions if you want your job to be done, and that would be handled using Python operator. We'll see that in subsequent slides. This is MWAA versus Apache Airflow. Okay, so this is managed Airflow. Managed Airflow is something which AWS is providing at their end. So it's the same Airflow, which is the Apache Airflow. You all know, right? Apache is an open source organization, and this Apache Airflow is free of cost. But when you introduce the term managed, it is something which is handled and managed by AWS services. So the only drawback or the only difference between Apache Airflow and managed Airflow is, in this case, you need to also take care of all the infra. You need to spin up a cluster, you need to then install the Airflow, you need to then make use of, you need to create a specific polling mechanism that whether your Airflow scheduler is running and it's polling at particular intervals of time. But in case of managed workflow, you do not have to worry about it. You just have to write a code. You just have to write a DAG, and that's it. You just push, and it will be there for you. No more no more that kind of stuff, maintaining stuff. So that's the difference between Apache Airflow and managed Airflow. Ideal for ad hoc and scheduled pipelines. So if you want to run something on the fly, on demand kind, then you go for this ad hoc system of the Airflow. Otherwise, you have scheduled pipelines wherein you can schedule a schedule interval. It can be daily 2 a.m., daily 3 p.m., etc., etc. Or you want it to run every half an hour or anything, right? It's scheduled. So both kind of properties is provided here. Next, let's move to this components part. Okay, so now we have covered the introduction. We have moved to components. So this is the first and primary component, DAG. I also said DAG a couple of times. DAG stands for directed acyclic graph. Okay, so generally your graph is something which is a closed graph, right? It starts from here and it ends there. It's a cyclic graph, generally a graph. But here it's saying directed acyclic graph. That means it is in a single direction. It is acyclic. That means the cycle is not getting closed, and it's a graph. Okay, so necessarily it means that you cannot start a task, then have some other task over it, then have some other task over it, and then in the end you club the first task as the last task. No, it's not a cyclic thing. Okay, so this is how a typical DAG is written. This is your DAG equals DAG, webinar hello world. This is the name of the task, right? What we can use. So here we'll be seeing webinar hello world as an example. So that's the name of the task ID. It is task underscore ID. The name present here is the name of the DAG that you have, right? We'll see what I'm trying to say here. We'll see in action. Okay, description. If you want to write any fancy description for the task or for the DAG that you have. Schedule interval daily, if you want it to be a daily thing. Start date pendulum.today. Okay, so pendulum is one such library which is giving you the option of having today, yesterday, or day -1 or day -2. So pendulum is nothing else. It's just a library which is giving you the kind of a date time, right? Earlier it used to have date time, just like we have in Python. Catch up false. Okay, so catch up is something which is just like your backfilling. So what is backfill? What is catch up? Let's take a moment to understand that. For example, you have a job which is running on a daily level, and now you want to run a job for a particular day which has elapsed 10 days ago, for example. So now you run you have provided the catch up as true, and whenever you run the job, and your job ran for 10 days ago, then it would start to run and start to see whether any of the day your job got failed or not. Okay, so in that case your backfilling would automatically happen, and the job which got failed 10 days ago or 11 days ago, right, that would get triggered again. This is an advanced topic, I would say, backfilling. So if you do not get it right now, it's completely okay also, right? When you dive deep into the Airflow components and you have a good experience about the handling and these type of things which are generally seen, then it would be much more easy for you to make a note of what backfilling and catch up and all of this is. Okay, so these were the DAG properties which you just saw. Next, we move to the operator. So again, a couple of minutes ago, I was referring to some operators. Okay, so here in this example, we see Python operator. Python operator is one such operator which is helpful or useful for running our Python programs. Okay, so that is the Python operator. There is a dummy operator. So dummy operator does, as the name says, dummy. It does nothing. Okay, dummy means it's just there to tell you that your task related to this thing got started and it got ended. Okay, start, end, etc., etc. So I'll go again to Python operator. Task ID, hello task, right? You can relate to this. So here we have the task ID is the first one. So here the task ID is a hello task. That means the Python operator, whatever task it is responsible to cater to, it will have your task ID as the hello task. And the Python callable will be print hello. Print hello is what? Print hello is the function, Python function. And the DAG is equal to DAG. DAG, what is this DAG? DAG is this DAG, right? So think of it this way, these are the key value pair kind of things, right? So keys are fixed, which are expected out of this operator, and the values are things which we'll be providing on the fly when we'll be creating a DAG. We'll again, I mean, you'll understand more on this when you see the demo of it, right? But bear with me for some time. Okay, next goes the dummy operator. Again, as I explained, dummy operator does nothing. It's just there to tell you that your task exists. So in this case, we have provided a dummy operator at the start and at the mid, right? Nothing fancy, nothing else. See, here it was calling a Python function. Here it's not doing anything. Again, we move to the bash operator where task ID is end, the task ID start, mid, and end, and the bash command would be echo success. Okay, so this is how your operator is. Bash, as the name suggests, it is used to run any kind of Linux or shell script. Echo success, or you could also have run your shell script, right? Something.sh. So that could also have been run using the bash command. So there are different operators which are there for different purposes. For example, you also want to work your way through EMR. So there are EMR steps operator, right? You want to have a run only a Spark jobs, for example. So there are Spark operators, Spark submit operator. So etc. etc. For different use cases, you have different kind of operators which are particularly meant for those. Otherwise, you can always use a workaround. You can always do something. You can always write something, and you can call it via Python operator or via bash operator. Okay. So these are the variables. So in the Airflow UI, when we'll see Airflow UI, we'll be seeing the variables. So for example, here I've given a cluster ID and loaded. So what are variables? If you say, for example, think of it this way. You have written a DAG, and now your DAG is being used at multiple places in multiple projects, for example, right? One such project has an EMR, right, which is of a different account. You have a project A, which is of a different account. Other is a project B, which is of a different account. Third is a project C, which is of a different account. Your DAG is common. You do not want to rewrite your DAG again and again, but you want your Airflow to recognize the EMR, right? The EMR, AWS EMR, which is on each and every account. Okay, so what I mean to say here is, you want your same DAG to work for account A's EMR, account B's EMR, account C's EMR. So what would happen? A typical case is you write your Airflow DAG and you put the value, etc., etc. So think of it this way: you just gave a variable there in your DAG as cluster ID, cluster underscore ID. This is made up name, right? Key is not a fixed key. You can give any name, XYZ, that would also work. And this is the ID of your EMR. Okay. So for think of it this way: now your DAG is just your DAG just got parameterized. Anything which is there for parameterization is handled by variables. You want to reuse your variables. You would want to reuse your variables. You would want to reuse your DAG just by using these variables. Okay. Now, if you have another account, so definitely you will have another. You can write another, cluster ID underscore B, for example, for account B. Therein you can have a value of their EMR, cluster ID underscore C. Therein you can have the cluster ID of that. So whenever, in whichever environment your Airflow DAG will run, it will pick up that cluster ID on its own. Okay. So that's the, I would say, that's the way of removing redundancy here using variables. Variables is just that, nothing else. Connections. As the name suggests, if you want to make connections with some of the other components, for example, with the databases, for example, with anything else, right? We there saw related to the Slack connections, databases, etc. So you can make the connections there. If you see, you have default. Oh, sorry. So if you see here, you have this Airflow DB as MySQL, AWS default AWS. These are the standard or the default set of connections which are there provided initially inside your Airflow. You can add more by clicking on the plus sign, and then you can add your similar set of further set of connections. Azure Batch default, Azure Data Lake default, Azure, etc., etc. Cassandra. So it has given you quite a few examples to get you started, to help you started. Okay, you will get all of this in the official pages of Airflow, and I've also attached the resources link in the last slide, so you can go there and you can see what all is there. XCOMs. Okay, so your XCOMs are primarily external communicators, right? If I'm not getting that wrong. So what it means is, for example, from one task you want to send some of the value which needs to be pulled from some other task. So that's the XCOM. It is kind of an advanced concept. It's not a very beginner's level concept. So it's absolutely fine if you do not get it in very much detail, but just to get a sense of it, what XCOM actually means is, you take it this way: the first task of yours, right? It got started and it has something which it wants to send to some other task, which is at the downstream side. That task picks your thing which is thrown from task one, and then it utilizes. So think of it this way. For example, you have think of, okay, in the real world example, in a very different kind of an example, think of it up as a relay race, right? There is one guy who has a baton in his hand, and that guy runs, and when he reaches to his point, not the actual finishing point, he passes the baton to somebody else, who then does the job, right? He moves from that point to the next point, and then he passes the baton to the next one. So in a similar way, you can do the XCOM push and the XCOM pull. So there are times when you want to do this, you want to do all of this. So that is the XCOM. Next is the sensor. So sensor is one other component, which means that which is used to check and handle whether a file actually was there or not, right? Whether something went there or not. Sensor, it is constantly polling and it is checking whether something happened or something did not happen. For example, here you say watch a step first, EMR step sensor. For example, this is the EMR step sensor. Task ID, we give the task ID webinar DAG 3 sensor. Job flow ID, cluster ID, again the cluster ID which we just saw. Step ID. So you see here task instance dot XCOM pull. Sorry for that. So task instance dot XCOM underscore pull. So what you did here, from webinar DAG 3, right, which was somewhere above this, it is pulling the output of whatever the task gave. I'll repeat this statement again. So XCOM underscore pull is responsible to read the output of some other task which was before this task, which the task name was webinar DAG 3, right? This task's name is webinar DAG 3 sensor. Okay, so this was there to read the output of that task. Okay, and here the key is the return value 0. This is something which it is if you are from Python background, you would know that this return value, it will be in the form of a list, and from the list it is just picking up the first value of it. So this would be the key of it, right? And AWS connection ID is AWS default. So now here what is happening is, this is the most critical part: XCOM pull task IDs equals webinar DAG 3. Here it is just assuming and just waiting for that output to be present. For example, if the task which was webinar DAG 3 did not give any output, any relevant output, then this would get failed. It would say, no, boss, I did not get anything, what I was expecting, right? So that is what the task of a sensor is. It will just progress. It will only progress when something was there. Think of it from this example. For example, you are making a pipeline for your upstream customer, right? And your upstream customer says that the SLA or that, for example, we'll be sending a file every day by 10 a.m. in the morning. Okay. And you have your job, which is running at 10:05. That, okay, by 10 o'clock, my file will come. At 10:05, my job will run. It will pick up the file on its own. But for example, something happens and your client, your upstream customer was not able to send you the file at 10 a.m. And your job at 10:05 would run and it would get failed. Now that is a problem here. So in that case, what you can do is, instead of putting your schedule at 10:05, you can just place a sensor at 10 o'clock. And you'll say that, okay, whenever that file gets present, whether it's 10:05, 10:10, 10:15, 10:30, after that, my job should run. Okay. So I think that gave a basic idea about what sensors is. Now here in the demo, we'll be looking at Airflow DAGs and would understand different properties and see the DAGs in action. Okay, so we'll go in the very same sequence. We'll not see the DAG in actions first. We'll just see the Airflow DAGs. Okay, so before we go there, I want you to see. Okay. Okay, so here if you see, you have this DAG. I think, is it visible? It's visible, right? I think it's visible. Let me just drop my screen share for once. It's visible, right? So if you see this, this is my DAG. Put it this way. Okay, so if you see this is my DAG one. Okay, so my DAG one from Airflow import DAG. Okay, this is a typical way of importing libraries in Python. So that's what we did here. Then DAG equals DAG, webinar DAG one, description, something, schedule interval 2. So see, remember the way that I explained you the cron job thing. So here you have given the schedule interval of 2 a.m. that daily at 2 a.m. it should run. Start date, it is saying pendulum.date time. It should start at 14/2/2023. Okay, catch up is false. We do not want anything related to backfill. Okay, now first is your dummy operator, second is your mid, third is your end bash operator. So bash operator is only giving me echo success. Okay, so till here I think we already studied a couple of minutes ago. Now what is this? This is my lineage. This is my downstreams. So for example, this start should run first, then your mid should run second, and then your end should run third. So this is the way that you have provided this. You can also write start dot set downstream mid dot set downstream end. That is another way. This is another way. Okay, so I hope this is clear. So now we'll see that this DAG, how our graph looks, and what is the, and whether we are able to see this error message, see this pass message success. Okay, so for that we have to run to this Airflow UI. Okay, so here we have this Airflow UI. Now I want you to show the variables which I show there. Like we have cluster ID, anything, any value, XYZ. Configurations, connections. Here, we saw all of this, docs, browse. It provides a plethora of other options, right? We are only interested in the DAGs that we have. So this is the webinar DAG one. Let's see. Let's see what all does it this have. Grid. This will show you how your DAG ran in the graph view, in the grid view. Sorry, this is the grid view. It will say, okay, the first one was start, then second one was mid, third one was end, and this has been the status of all of that. Right. It will also explain you the details of max run duration, how much time it took, and all of that. Right. Total tasks, total success, total runs displayed, and all of that. Empty operators. Now next is the graph. So if you want to see your start, mid, end, this is dark green right now, which means it got success earlier. Now when we'll run again, we'll see this is in a green state. So before we move on, let me show you this code. So code is the same which we in the shell, right? DAG, description, schedule interval, start date, dummy operator, bash operator. Okay, this is my ad hoc run. I am doing this and going to trigger DAG. Right now, you see when you did this, this is in a light green form. Right, you can see here this DAG just got started. It's not in dark green. If you see here, these got dark green because they're already processed, but this is still in gray state. Okay, now eventually this would turn into light green and then it would turn into dark green. Let's wait for this to happen and then we'll see the logs. See, so when it says it's in light green, this means that it's in running state right now. Okay, so now we are waiting that, okay, what did our end do? Our end was only responsible to print success. Okay, let's see, let's find out if we are able to find the message success or not. I went to here, I went to logs. So, the way to go to the logs is to click on your task, and then you have other set of actions also. You can click on run if you want to rerun that. If you want to again rerun and clear the status of the current task, you need to do is clear. If you need to mark it as failed, if you need to mark it as success. So these are something which comes into play when you want to manually change the status. For example, your job got failed, but you want to show it as success. You see that, okay, no, my job got success. It's something else which is telling it that it got failed. Some intermittent infra level issue, network issue. Okay, so here we are not interested in other things. It would be too much information in that case. Let's go to logs and let's see success. So here, see, info is success. That's the output. Okay, so DAG ran fine. This was the first Airflow DAG. Okay. Okay, you can post your questions if you have any questions pertaining to this. Let's move to the next one. Okay, so I'll go there. Right now, if we see the other Airflow DAG for this webinar, we have this webinar DAG_2. Right, let's show you this. Okay, here what we are trying to achieve is again your typical import statements, Airflow operators, Python operator import, pendulum, and all of that. Now here we are making use of Python operator. Earlier we saw dummy operator and your bash operator. Here we are making use of Python operator. Okay, so here I have created a typical Python function def print hello, right, and it will return hello world from first Airflow DAG. Okay, so this is something that we'll be looking for. So earlier in the example, we saw success, right? That was something which was being echoed by bash operator. Here in the Python operator, this would be something which we'll be looking for. Now your typical DAG webinar hello world. See, the way your webinar hello world is written here is the same which is written here. In the earlier example, webinar DAG1 was written here as task ID. That is something which is written here. So this task ID determines what is going to be the name of your DAG. Okay, description hello world DAG, schedule interval daily, start date pendulum today, catch up calls. Hello operator, Python operator, task ID is hello task, right? So if you see inside this, see hello task. This hello task came from here, from this task ID of Python operator. Okay, Python callable means this will be calling this print hello function from here. Okay, so this Python callable will be calling this. That means this operator is responsible to run this function by this Python callable. DAG is equal to DAG. This is a typical key, and this is the value. This is the value. We could have also given this as XYZ, and DAG is equal to XYZ. That would also have worked, right? But in general, as a good code practice, we generally give it as DAG. And in the last example, we saw start greater than mid greater than end, right? Which means it was creating a lineage. But here it's because we just have one operator, therefore we just have one operator function, or I would say variable written here. Okay, let's go there. Okay, so now we are here at the webinar Hello World. Let's see our code, what our code does. This is exactly similar thing which we just saw. This is what our code did. Now let's again click on trigger DAG. Let's see if grid is able to show us something. Yes. So this again went to light green. It is in the auto refresh state. So that means I do not need to manually, go and refresh it again and again. Let's go to graph. Again, it's in auto refresh state. I do not need to manually go and refresh it again and again. There are other set of components also: calendar, task duration, task tries, landing times, etc. But these would be, again, I would say, too much information, and they are not generally used. They are for very typical or particular use cases. Okay, so it went to green, light green, and then it went to dark green. Let's see. Let's check the logs. Okay, what were we supposed to find? We were supposed to find hello world from first Airflow DAG. Okay, so return value was hello world from first Airflow DAG. See, our job got passed here, right? Now if you want to do anything to, you can play around with this. It's just free of cost. You can simply install it and simply run it. There's just one more thing which you need to make sure when you will be starting this. There are two components to this. One is Airflow web server, other is your Airflow scheduler. So this needs to be run in parallel. What does these two do? Let me tell you. So web server is responsible for giving you this Airflow UI, the UI which is at the backend, right? This UI. This is something which is present from Airflow web server. Other is Airflow scheduler. It is nothing. It is just, responsible for showing you any of the DAG which you just pushed. For example, I made some changes to this DAG, and then my Airflow scheduler is running. Okay, this is my Airflow scheduler which is running, and my Airflow scheduler would automatically take that DAG and put it here in the list of all DAGs. Right, I've only activated this. So there's one more point related to activation and deactivation. What all are deactivated would not run on its own, but what all are activated DAGs would run at the schedule interval. Okay, so if you see the history of it, for example, for webinar DAG 1, you go here, the timing was 2 a.m. daily, right? So if you see, it ran on 17th at 2 a.m., on 16th at 2 a.m., on 15th at 2 a.m., etc., etc. Right? So this has been running daily on its own. If I toggle this button and switch it to off, then it would not run on its own. Okay, so that's it about the demo. Okay, it's also giving you the scheduled. What's the schedule time here? Next run. When is the next run scheduled for? So it's scheduled for this time. Right. Let's go back to our PPT. Right. These are the resources, and we are good to close. Any questions that we have? We take that. So what all questions do we have? Please use. Okay. We are running out of time. Can you please help me with the questions? I'm not able to find the questions. What all questions do we have? Hello, Suchitra. How will it handle daylight saving? Okay, So good question here, Subhashish Mishra. In the daylight saving, so if you want to, for example, work as a daylight saving, you saw that here we have a schedule interval, right? And after the schedule interval, there is also one option of TZ and time zone info. So there you can, so there you can put in as your IST or your UTC or your, PST or what all times you want, and it would take the timing of that area on its own. But if you think or if you feel that according to a daylight saving mode, it will automatically add 1 hour or it subtract 1 hour, then it's something which it's not capable of. You will need to manually add or subtract that, right? But it will definitely take the time zones accordingly, whatever you wanted. I hope that I was able to answer the question. Any other question that we have? Hello, Suchitra.
Yeah, Hardik.
Yeah. So I think we just had one question, right? This time, which was pretty new to me.
Mm,
Okay.
Maybe they have put it in chat box. Let me check if
Yeah, yeah.
somebody.
Mhm. Thanks, Hardik. Okay. What type of errors you can expect? Okay. So here we are getting some questions. We are running on. Okay. Okay. What type of errors you can expect on executors? Executor. I hope you're talking about Spark executors, right? And if you're talking about the Spark executors, then that is something that I'll definitely answer, but that's not something related to Airflow. So I'll take that. I'll assume that you're talking about the Spark operators, Spark executors. So errors in Spark executors can range from your out of memory errors, your resources are limited, so it can vary. It can vary accordingly. Basically, think of it this way, that when your job is running and it is going on your executor, so what kind of errors you can think of, right? First can be the kind of error related to your application. For example, you have not handled some edge case in your code base, right? That can be something. So when you have not written or not catered to some of the values in your use case, it would be an application side bug. It would be a code issue. So that is something which can which can get you in trouble while at executor. So when you say that your job is running on executors, it is running on deploy mode cluster. Now this was the application issue which we just talked of. Second could be your infra level issue. When we say infra level issue, uh, that means that your executor it was not able to find enough executors for the kind of job that you're doing. Okay. Or your executor is not having enough memory, enough RAM, so it's running out of memory. One more edge case, one more point what I can think of is, for example, you are again running into EMR. I'm taking the example of EMR again and again is because that is one of the very prominent execution capability or execution possibility which is there in today's time. So let's say we are on EMR and we are talking about spot instances. Okay, so it can also happen that you have maintained an EMR fleet of spot instances, and you have asked for some machine and that machine is not available. So now your job is requesting for some of the executor of that particular machine, but your machine is not available, right? And your job got failed. So that can be another set of issue. I think I was able to answer the question. Yes, on EMR. Oh, okay, great. Should be handled by Spark itself. Yes, yes, yes. Uh, that should be handled by Spark itself. Right, right. So I told you, right, if it's an infra level issue, then yes, definitely it is something which you need to understand from your visualization tools. You could have Datadog, you could have Grafana, Prometheus, etc., etc. Any other visualization tool, or if you're working on AWS, then you can also have on CloudWatch, right? Yes, you should check at application level and at infra level, right? So I was saying on CloudWatch, you can see, and you can also see on your Spark History server, right? On Spark History server, you can check how your DAGs are working, whether your lineage is working, is getting fine or not. What all stages do you have? What all tasks do you have? It could also happen that you are having so much shuffling, right? You're having so much wide shuffling that your data is getting out of the way. It's getting out completely out. So you need to check and see all those lineages, how it's working. So I think I was able to answer this question. Okay, I guess then we are good. We're almost on time. We do not have any other question.
Okay. Thanks a lot, Hardik. On the behalf of Analytics Vidya, I would like to thank you for your time and for delivering us such a wonderful session. I'm sure our audience are found it insightful, and hopefully we can conduct more such sessions with you in the future. So,
Sure.
attendees, you can connect with Hardik Goel in on the LinkedIn profile as I shared in chat. I hope you guys have filled in the feedback poll. If not, I request you to please fill in the poll about feedback, as it help us to conduct more such sessions. Okay. So guys, we will be back with another session of the data hour. In the link is share in the chat section. Till then, bye bye and keep learning.
Thank you. Thank you, guys.
Yeah, thank you, Hardik. Thank you, all of you guys. Bye.